In this section, we're going to talk about what does it mean to find the domain of a function. So you might have heard the words domain and range before. In this section, we're only going to talk about domain. So we have a function. We can just make one up, maybe like x squared over x plus 3. And we want to find the domain. What this means is we want to find any x value we can plug in here and not get an undefined. So before we write that down, just off to the side, let's write what does it mean to be an undefined. So an undefined is going to happen in two situations. The first is, say if we have just any number on the top, let's just call it 1. And we plug in a number in here and somehow we get a 0 on the bottom. So this can't happen. We can never have a number on the top and then a 0 on the bottom of a fraction. So this would be an undefined. Another issue or situation we can have is, say if we have a square root and somehow we end up getting a negative number in here, like a -3. So these are two things that we can't have. You can't have this negative, so no negative in the square root. And then we also can't have 0 in the bottom of a fraction. So when we're looking, say for example in this problem, when we're looking for the domain, all the x values we could plug in, we're trying to look for all the x values we can plug in, and either this or this won't happen. So right off the bat, we see, say if we plugged in -3 into this equation. So we know just to plug in -3 for x, we'll have -3 squared. And then plug in -3 right here, so we get -3 plus 3. -3 squared is +9. -3 plus 3 is 0. So here you see we have a number on the top and a 0 on the bottom, so we can't have this. Because this is undefined. So this tells us that -3 is not in the domain. The domain is all the values that we could plug in and we don't get an undefined. But when we plug in -3, we do get an undefined. So what this tells us is -3 is not in the domain. Okay, so this is just a little example to show what does it mean to be in the domain or not to be in the domain. I guess just to do one more little thing. How about f of 1? If we plug in 1, we're going to get 1 squared divided by 1 plus 3, which is just equal to 1 over 4. And that's okay, so that doesn't look like this and it doesn't look like this. There's no 0 on the bottom and there's no square root with a negative on the inside. So 1's okay. This tells us that 1 is in the domain. But this is not how we technically find the domain. This would take forever, plugging in every single number you can think of. So on this next page, just write just a couple of steps that we can follow that'll allow us to find the domain. So like certain steps, the first one is, we said let's write these situations down again. So these are the two situations that we don't want to have. We don't want to have a 0 on the bottom of a fraction, and we don't want to have a negative inside of the square root. So when we're trying to find a domain and we're given a problem, the first thing we do is ask ourselves two questions. The first is, are there fractions? And at the same time, we ask ourselves, are there square roots? So again, we're asking ourselves these two questions because if there's a fraction, well, we have to make sure the bottom of the fraction can't be 0. If there's a square root, well, we have to make sure the inside can't have a negative in there. So let's do the next step. So suppose, let's call this like little part A and this is part B. So suppose the answer to A is yes. So if A is yes, what we then do is just set the bottom of the fraction equal to 0. So then set the bottom of the fraction and solve for x. So you're going to get some x values, and then we'll write this step down too, and this will all be more clear with an example. But then once we solve for x, we write a number line, and put circles on the values that we found in when solving for x. Okay, so now say if, and also, so if a is no, then you just don't even do anything. So if a is no, then don't do anything. Okay, so let's go to the question B. Are there square roots? So let's say if B is yes. So if B is yes, well, we said we don't want a negative inside of our square root. So suppose what we want to do now is then just take the inside of our square root and set it bigger than or equal to 0. So what we want to do is take the inside of the square root and then put a bigger than or equal to sign and then a 0. And then we want to solve for x here. And then what we would do is just graph these numbers on a number line. And just like before, if the answer to B is no, then you don't do anything. Okay, so for any domain problem, these are going to be the steps that we need to follow. And every single time if we follow these steps, you'll get the right answer. So this next page, let's go over a couple of examples and different scenarios that we would have. Okay, so first example. So say if we have something like 3x to the 4 minus 7x plus 1. So when we're finding the domain, we always ask ourselves those same two questions. Are there fractions and are there square roots? So we see just from looking at this, there's no fractions. There was a fraction, there'd be a fraction sign. So in this situation, there's no fractions. Okay, so now the next question was, are there any square roots? And again, if we look at this, there's no square roots. And whenever this is the situation, like we said in the previous page, when there's no fractions, you don't do anything. When there's no square roots, you don't do anything. And with this, whenever we come into this situation, no fractions, no square roots, we're not doing anything, this means the domain is all real numbers. Or on a number line, what this means is the domain is everything. So we could shade in all this. And then, so this would be in graph notation. And then if we put this into an interval, this would be minus infinity all the way up to infinity. And this would be interval notation. So again, what is this telling us? So the domain is all the values we can plug in here and not get an undefined. What this means is any single number from minus infinity all the way up to infinity, we plug it in here, we weren't going to get an undefined. So we're not going to get a 0 in the bottom of a fraction, and we're not going to get a square root with a negative on the inside. And so that's because, like, well, we saw there was no fractions, so it's impossible for the bottom of a fraction to be 0 here, because there are no fractions. And there's no square roots, so since there's no square roots, it's impossible for us to get a negative inside of a square root. So again, that's sort of why the domain is all real numbers. So minus infinity all the way up to infinity. Okay, so the next example, let's do this one. So 1 divided by x squared plus 8x plus 7. So just like any other domain problem, we start by asking ourselves the same questions. Are there fractions and are there square roots? So this one, we do have fractions. So yes to fractions. And so in the previous page, we said if we have a fraction, what we want to do then is set the bottom of the fraction equal to 0 and then solve for those x values and then plug those x values on a number line with a circle. So the bottom of this fraction is x squared plus 8x plus 7. And we set this equal to 0. And in order to solve this problem, we need to factor. So we have to factor this left-hand side. And when factoring this left-hand side, we notice that there's a 1 in front of the x squared. And whenever that's the case, we just draw two sets of parentheses. We put an x here and an x here. And now we look for numbers that multiply up to 7, but then add up to 8. So that's going to be plus 1 and plus 7. Since 1 times 7 is 7, 1 plus 7 is 8. And then in order to keep solving this, we have to set each of these pieces equal to 0. So x plus 1 is 0. X plus 7 is 0. Here x is minus 1. And here x is minus 7. So we, again, just the previous page said we have a fraction, set the bottom of the fraction equal to 0. Then you get these two numbers, write them on a number line with a circle. So here's our number line. Here's minus 1. Here's minus 7. Here's minus 1. And we put circles on them. All right, so now remember, we have to ask ourselves another question. Are there any square roots? But again, looking at this problem, we don't see any square roots. So there's no square roots. So when there's no square roots, we just don't do anything with that step. So what we just found was when there's fractions, the bottom of this fraction can only, so that's what we did. We set this bottom of this fraction equal to 0. And remember, we can't have the bottom of a fraction being 0. But when we set our fraction, the bottom of it equal to 0, we see x is minus 1 and x is minus 7. So what this tells us is, if we plugged in minus 1 to this problem, so to this equation, we're going to get a negative or a 0 in the bottom of this fraction. If we plug in minus 7 in here and we did everything, we'd get a 0 in the bottom of the fraction. So we can't be these two numbers, which is why we put a circle on here. Because remember, circle means we don't include this minus 7 and we don't include the minus 1. Whereas a closed dot means we do include the minus 7, and a closed dot here would mean we would include the minus 1. So after doing all this work, the only time we get an undefined is at this number and this number. But all the numbers in between don't give us an undefined, and the numbers over here don't give us an undefined, and the numbers over here don't give us an undefined. And again, we know that is because the only time we have an undefined is if there's fractions and is if there's square roots. So when there were fractions, the only problems that we had were at minus 1 and minus 7, so we get rid of those. And then the only other time we can have a problem is if there's a square root, but there are no square roots. So none of these other numbers can give us a problem. So now we want to, this is the graph notation. We want to put this into an interval notation. And so how we do that is, so this is 3 separate intervals. We have minus infinity up to minus 7. And remember, there's a circle here, so we have to put a parenthesis. And then this little symbol we use to connect these intervals is this union symbol. So it's just like an upside down U, or sorry, a regular U, not an upside down one. Then the interval in between, so minus 7 to minus 1. Then the U, and then minus 1 all the way up to infinity. Okay, so for this problem, this would be our domain. All these numbers except minus 7 and minus 1. Okay, let's go on to the next example. Okay, so in this one, sort of similar to the previous one. So here's x plus 3 over 4x squared plus 13x plus 3. Okay, so just like any other domain problem, we want to start with asking ourselves the same two questions. Are there fractions and are there square roots? So let's just start with the fractions one. Again, the answer is yes here. We see this whole thing is a fraction. Here's the top of our fraction, here's the bottom of our fraction. But remember, all we need to do is set the bottom of the fraction equal to 0. So when we're asking ourselves the fraction question, again, we have yes to fractions. The top of the fraction has nothing to do with this part of the problem. Only if there's fractions. So here's the fraction, here's the bottom of the fraction. So all we need to do, even though there's an x up here, that doesn't matter. Just when we're talking about the fractions, all that matters is the bottom of our fraction, and all that matters is setting it equal to 0. So what we want to do now is set the bottom of our fraction equal to 0. So we have x squared plus 13x plus 3 is equal to 0. And now we want to solve this. And just like before, we need a factor. But now in this situation, we don't have a 1 in front of our x squared. We have a 4 here. So we need to do the AC method. So remember, here's ax squared plus bx plus c. And to find the AC method, we have to take our a times our c. So that's going to be 4 times 3, which is 12. And now we need to find up all the numbers that multiply up to this number, but also add up to this middle number. So let's start with what multiplies up to 12. So we have 1 and 12. That ends up being the right one we need. So 1 times 12 is 12, and 1 plus 12 is 13. So this is the pair that we need. And so once we find this pair, remember, we have to replace this middle number with, instead of having 13, we're going to do 1 plus 12. So this is going to turn into 4x squared plus x plus 12x plus 3 is equal to 0. So again, instead of writing 13x, we write 1x plus 12x. So this 13x and this x plus 12x are the same thing. So this part and this part are still exactly the same. All we did is rewrote this 13 as 1 plus 12. Then what we do is, remember, we group these first two together, group these second two together, and then we factor out from those. So from this first one, we can just take out an x from this piece and this piece. So if we take out an x from 4x squared, we're left with 4x. And if we take out this x right here, we're just going to be left with a 1. So remember, if we multiply it back through, we need to get this. So x times 4x is 4x squared, and x times 1 is x. So that's okay. Now in this next one, we can take out a 3. So 3. If we take out a 3 from 12x, we're going to get a 4x. And we take out this 3, we're going to be left with a 1. So again, 3 times 4x is 12x. 3 times 1 is 3. So that's good. And now the last thing is, so you see we have another piece in common between this and this. There's a 4x plus 1 here and a 4x plus 1 here. So we're just going to take out the 4x plus 1. So 4x plus 1. And if we take out the 4x plus 1 from this term, we're just left with this x. And if we take out the 4x plus 1 from this term, we're just left with this 3. Okay, so now we're at these two pieces equal to 0, so we just set both of them equal to 0. 4x plus 1 is equal to 0, x plus 3 is equal to 0. Solving for here, we subtract the 1 over, so 4x is equal to minus 1. Then we divide by the 4. X is equal to minus 1 over 4. Okay, so there's our first value. And this one, to subtract the 3 over, x is equal to minus 3. So again, what did we just do? Well, we saw that we do have fractions, and whenever we do have fractions, we just set the bottom equal to 0, because we can't have the bottom to be 0, so we want to figure out what x values do that. We set the bottom equal to 0, we did all this work, and we see when x is minus 1 over 4, and when x is minus 3, the bottom of this fraction is going to be 0. So then what we do, just like before, here's our number line. Okay, so here's minus 3, here's minus 1 over 4. And we're going to put circles on those because we're getting rid of these numbers. When we plug in minus 3 or when we plug in minus 4, the bottom of this fraction is 0, and we can't have that. Okay, so that takes care of this, the fractions. We said, are the fractions? Yes. So the bottom equal to 0. The only two numbers that we can come up with is this one and this one. And then the next question is, are there square roots? But if you look at this, you don't see any square roots. So no square roots. So we don't do anything there. So the only problems are these two numbers, the minus 3 and the minus 1 over 4. But everything here is okay, everything here is okay, and everything bigger is okay. Okay, so then that's the graph. Now if we put it into an interval, we have minus infinity to minus 3, minus 3 to minus 1 over 4, and then minus 1 over 4 to infinity. Okay, and so for this one, this will just be the answer. All right. Our next example is just this one right here. So this is the square root of 5x minus 1. So we want to find the domain of this, and always just ask ourselves the same questions. Are there? We'll start with the fractions. Just from looking at this, we don't see any fractions, so there's no fractions. So when there's no fractions, then we don't do that fraction step. The fraction step was setting the bottom of the fraction equal to 0. If there's no fractions, then there's no need to set anything equal to 0 because there's no more fractions. But there are square roots. We see this whole thing as a square root. So yes to square roots. And then what we said before is when we have a square root, we just take the inside of our square root, so this 5x minus 1, and we just set it bigger than or equal to 0. Sorry, I might have made a mistake in the notes. So on our first page, we had this. I wrote that we just have a bigger than sign here. So for if b was yes, so are there any square roots? We have to set the inside of the square root bigger than 0. It needs to be bigger than or equal to 0. So this needs to be a bigger than or equal to sign, not just a bigger than sign. So set the inside of the square root bigger than or equal to 0. And then now we're just going to solve for x. So we can add this one over. So we get 5x is bigger than or equal to 1. Divide by the 5. X is bigger than or equal to 1 over 5. So remember, what are we looking for here? When we have a square root, we can't have the inside being negative. So we want to have our inside, this 5x minus 1, we want that to be a positive number or bigger, just bigger than or equal to 0. And we see now from doing this work, this piece right here is bigger than or equal to 0 when x is bigger than or equal to 1 over 5. Because we set this thing bigger than or equal to 0, and we did some work, and when we manipulated everything, we see x must be bigger than or equal to 1 over 5. So when x is bigger than or equal to this number, this inside is bigger than or equal to 0, and so that's okay. We want this inside to be bigger than or equal to 0. So when we go to our number line, here's 1 over 5. We want to shade all these values bigger than or equal to 1 over 5. So since it's this or equal to part, we're going to put a closed dot on 1 over 5 because 1 over 5 is allowed to be in here. 1 over 5 is bigger than or equal to 1 over 5. And then we shade bigger than. So all the numbers that are bigger than this are to the right. So we're going to shade to the right. But notice then all these numbers to the left here, that would make this inside negative, which we can't have. So we don't shade in anything to the left. We're only shading these numbers, x bigger than or equal to 1 over 5. Okay, and so there's the graph. And then if we put this into an interval, now we have a bracket on the 1 over 5 because there's a closed dot here. So we're going to have 1 over 5 all the way up to infinity. So these two answers, the graph and here's the interval. Okay, so our last example for domain. Okay. So just like before, let's ask ourselves the same questions. Are there fractions and are there square roots? So let's start with this, the fractions one. So the answer is yes, there is a fraction. Here's the top of our fraction, here's the bottom of our fraction. So we have yes to fractions. So what do we do when we say yes to fractions? Well, we take the bottom of our fraction and set it equal to 0. So the bottom of our fraction is this, x squared minus 2x minus 15. Set that equal to 0. And then just like before, we have to solve for x because we can't have the bottom of this fraction be 0. So we have to figure out what are those x values. So again, here we have to factor this. So this is, we see there's a 1 in front of our x squared. So we put 2 sets of parentheses. Always put an x here and an x here. And the numbers that multiply up to minus 15, but then add up to minus 2. So that's going to be negative 5 and plus 3. So negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. And then we set each of these pieces equal to 0. So we get x is 5 and x is minus 3. Okay, and now just like before, what we did is we went to a number line and we put circles on these numbers. So here's minus 3, put a circle. Here's positive 5, put another circle. All right, but before we shade anything, let's ask ourselves the second question. Are there any square roots? So before we do any shading, we're going to complete both of those questions. We said yes to fractions, but there's also going to be a square root. There's a square root in the top. So yes to square roots. And so remember just before, when we have a yes to square root thing, what we do is take the inside of our square root, this x plus 3, and just set it bigger than or equal to 0. And so then if we're solving for x, subtract the 3 over, so x is bigger than or equal to minus 3. So now we need to do some shading and also take care of this. So this is telling us that x can be bigger than or equal to minus 3. So remember the previous example up here, we have x is bigger than or equal to 1 over 5. And that was the only thing that we had here. And we didn't have these circles or anything else in play. All we had is x is bigger than or equal to 1 over 5. So we put a closed dot on this and shade it to the right. Here this is telling us that x is bigger than or equal to minus 3. So if it was only this and we didn't have any of this top stuff, we would put a closed dot on minus 3 because this is bigger than or equal to. And then we would shade to the right since x is bigger than it. But we already saw that x can't be minus 3, so we can't shade in. We already put a circle on this minus 3, so we can't shade in this in with a circle. But x is allowed to be bigger than minus 3, so we'll shade everything to the right, and whenever we pass over a circle, we have to skip it. So again, 5 is bigger than or equal to minus 3, but we already put a circle on 5 from the fraction part, so we have to skip that, and then we have to keep shading. So again, x is bigger than or equal to minus 3. If it was only this, we would shade in this minus 3 and shade everything to the right. But we already saw from the fraction part that x can't be 5 and x can't be minus 3. So we put a circle on minus 3 and a circle on 5. And so when we have the circles on minus 3 and 5, and then we also do this, we end up getting just all the shaded section right here. So then here's the graph, putting this into an interval, we're going to get minus 3 up to 5. The union, and then 5 all the way up to infinity. Okay, so then for this problem right here, this is going to be the domain, these two things. Well, they're the same thing. This is the graph, and then here's the interval. Okay, so the last bit from this section is just simplifying like fraction problems. So got a couple more examples to do. So this first example, x squared plus 5x plus 4 over x plus 8 times 3x plus 24 over 2x plus 8. So when we want to simplify this, we saw earlier when you're multiplying fractions, all you need to do is multiply this times this. So multiply the tops and multiply the bottoms. If we do that, it's going to get really messy. So what we want to do first when we have a problem like this is just factor everything that we can. So if we're going to factor, we can factor this top. Again, here we have an x squared with a 1 in the front. So here's our fraction sign. And we know to factor that, we just put 2 sets of parentheses. Put an x here and an x here. And now look for the numbers that multiply up to 4 and then add up to 5. So that's going to be 1 and 4, since 1 times 4 is 4 and 1 plus 4 is 5. This x plus 8, that can't be factored, so we just rewrite it. This 3x plus 24, this can be factored. We could take a 3 out from both of these pieces. So we could take a 3 out. If we take a 3 out from this, we're just left with an x. And if we take a 3 out from the 24, we're just left with an 8. And on the bottom again, we can also factor. So we could take a 2 out from both of these pieces. Then we're left with x plus 4. Okay, so now what we can do is just multiply everything across, but we're not going to do any foiling. We're just going to write every piece down with one fraction sign. So when we're multiplying across, we're going to get this thing times this thing times this thing times this. So let's just put this 3 into the front. So we'll have 3, x plus 1, x plus 4, x plus 8. And then this times this times this. So again, let's just put this 2 in the front. Then x plus 8. X plus 4. And now what we can do is see if things cancel. So on the top, you see we have an x plus 8. On the bottom, we have an x plus 8. On the top, we have an x plus 4. And on the bottom, we have an x plus 4. So then our final answer is just going to be 3 times x plus 1. And all that's left on the bottom is this 2. All right, so for this one, this will be our answer. Okay, so our next example, we'll do a divided by b minus b divided by a all over 1 over a plus 1 over b. So in this problem, we have fractions on the top, fractions on the bottom, and this whole thing is a fraction. So like here's the top of your fraction, here's the bottom, but on the top we also have fractions, and the bottom we also have fractions. So whenever that's the situation, let's first start by just combining the fractions on the top and combining the fractions on the bottom, and just forget about this whole big fraction. So if we combine these fractions on the top, well, we need to get a common denominator. This one has a b in the bottom of it, this one has an a in the bottom of it. So the common denominator is going to be ab. So here's our ab minus b over a. But if we want them to be the same, let's put an a in the bottom of this one, and then an a on the top of this one. And we'll put a b in the bottom of this one, and a b on the top of this one. And then on the bottom over here, so here's 1 over a. Again, we're going to have the same common denominator. We'll put a b in the bottom of this one, a b in the top of this one, and then over here we'll put an a in the bottom of this one, and an a in the top of this one. So then what do we get? So here is a times a, which is a squared. B times b is b squared. And we have the same denominator, so we can just write one fraction, and this is going to be ab. So again, here's your ab. We have the same common denominator, which goes right here. A times a is a squared, minus b times b is b squared. Okay, so now on the bottom, here's b times 1, which is just b, and here's a times 1, which is just a. So we have b plus a all over ab. Okay, so now all we did here is we just simplify the top, simplify the bottom. But now we have, this is sort of something that we did in one of the previous videos. Here we have a fraction divided by another fraction. So whenever we have that situation, we take our top fraction, the a squared minus b squared over ab, put a multiplication sign, and then we're going to write our bottom fraction, but have it turned upside down. So instead of having b plus a over ab, we'll have ab over b plus a. But now this is the same exact problem that we did previously. We have a fraction times a fraction. And whenever we do this now, we want to see, can we factor this, can we factor that, or can we factor this, or can we factor this? This piece right here, a squared minus b squared, this one can be factored. This is factored into a plus b, a minus b. So here's ab. We can't factor ab, again, we can't factor ab. And there's nothing we can do to factor b plus a. And then now we want to see, can things cancel? So here's an ab on the top, and here's an ab on the bottom, so we can get rid of those. Here's we can put this in parentheses, this b plus a on the bottom, a b and an a plus b on the top, so those can go away. And then all we're left with is a minus b. And this will be our final answer. And so one step that might have been kind of confusing is when we factored here, a squared minus b squared is a plus b, a minus b. That is sort of just a formula that, well, we can also figure that out. We can figure that out on a separate page. But whenever you have something like this, something squared minus another something squared, you get rid of the squareds and you always do a plus, so you know, this thing plus this thing, a plus b, this thing minus this thing, so a minus b. On the previous page, or the last page, we'll go over why that actually is true. But anyway, we do all the simplifying, and then we end up getting just a minus b. Okay, the last problem, well actually let's go over that factoring thing. So why does a squared minus b squared equal to a plus b, a minus b. Let's rewrite this. Let's show this one since we've been using the letter x. So x squared minus b squared. Well, let's keep all the letters the same. So x squared minus c squared is equal, this is going to be equal to x plus c, x minus c. So this is the same thing. All we're doing here is instead of writing an a, we're writing an x. Instead of writing a b, we're writing a c. Because these are the letters we've always been using, like the ax squared plus bx plus c. So in order to show this, well, all we want to do is factor this. Well, we see that there's a 1 in front of the x here. And whenever that was the case, we always write 2 sets of parentheses, put an x and put an x. And then what we always look for is numbers that multiply up to the last thing, but then add up to the middle thing. So just off to the side, the middle thing here is 0, because we can rewrite this as x squared plus 0x plus c squared. So the number at the very end is c squared, and the number in the middle is just 0 times x. So normally we always find the things that multiply up to this and then add up to the middle. So what are the two things that multiply up to a minus c squared? Well, that's going to be minus c and plus c. And at the same time, minus c plus c is 0. So that's how we could just show, without having this little formula memorized, that when we factor this, we just end up doing the same techniques as that we've been doing when we have been factoring. Okay, anyway, so besides that, the last problem we want to do is x squared plus 2x plus 1 over x plus 7 divided by x plus 1 over 2x plus 14. Okay, so the first thing we're going to do is let's get rid of this division sign. So we remember that when we have division, we just rewrite our first fraction. Put a multiplication sign, and then turn this other fraction upside down. And now we multiply. And again, we know when we multiply now, the first thing we want to do is just factor these tops, the bottoms, and everything, just to make it all simplified as possible. So if we can factor this top one, this is going to factor into x plus 1, x plus 2. Again, there's a 1 in front of the x squared, so we put an x here and an x. No, this has to be a 1. Again, we're looking for numbers that multiply up to this last one and add up to the middle. So 1 times 1, that's 1. 1 plus 1, that's 2. So this x squared plus 2x plus 1 factors into x plus 1 times x plus 1. We can't factor x plus 7, so we rewrite it. And then here we could take out a 2. So we're going to have a 2, and then be left with an x plus 7. Again, so 2 times x, that's 2x. And then 2 times 7 is 14. And on the bottom, we just have our x plus 1. So here we see that this x plus 7 cancels with this x plus 7. This x plus 1 cancels with this x plus 1. And all we're left with is 2 times x plus 1.